Ever since the speed of sound barrier was broken, people have turned their attention to how can we break the speed light barrier. But thanks to Einstein, unfortunately now we know that nothing, literally nothing in this universe can travel faster than the speed of light. In fact, we cannot even travel at the speed of light. The closest star to Earth is Proxima Centauri, which is about 4.25 light years away from us. That means just 40 trillion kilometers. You know, the fastest ever spacecraft that is now in space, Parker Solar Probe, would take just 20 seconds to go from India to Indonesia. Well, that sounds really fast, but it would take 6,633 years to reach Proxima Centauri. So if humanity really wants to travel between stars, people will have to travel faster than the speed of light. Well, talking of faster than light travel, Star Trek fans know how to do it. Warp drive. Well, warp drive is seemingly nothing more than science fiction, but it really does make faster than light travel possible. At least in movies. But wait, that's not the end of the story. Have a look at this now. Here's a paper being published in the month of March this year. It says, physical warp drives are possible, and that too without breaking the laws of physics. So what do you think? Will we ever be able to make it happen? Okay, today let's go on a journey faster than the speed of light, and let's explore warp drive. Let's go. Hello Stargazers, I'm Khushi and you're watching Space Girl. Alright, now to make sure that everyone is on the same page and assuming that you are among the unlucky people who haven't got the chance to watch Star Trek, including me, let's first explore what is warp drive and how does it work. Well, warp drive first came from science fiction, most famously Star Trek, but scientists have been theorizing and studying about faster than light travel since decades. One major reason being, we are never making it to our nearest star system without a warp drive. Our current understanding of warp speed dates back to 1994 when a theoretical physicist, Mikhail Alcubierre, first introduced what we today call Alcubierre Drive. He used Einstein's theory of general relativity to develop a mechanism that would allow faster than light travel within the confines of laws of physics. The key idea is that to make it happen, the ship itself doesn't have to travel faster than light. So to travel faster than light, you don't have to travel. But how is it possible? Okay, I'll get onto it in a moment, but before that, the theory of relativity says that nothing in this universe can travel faster than the speed of light. So speed of light is the ultimate limit. Now this speed barrier is because of a reason. Okay. Special relativity gives us a very famous formula which even a primary class student knows today. Yes, E equals mc squared, where E is energy, m is mass and c is speed of light. This equation gives us mass-energy equivalence, meaning mass and energy are two faces of the same coin. Mass and energy are equal. Mass can be converted into energy and energy can be converted into mass. Okay, now here's the thing. The kinetic energy of an object equals half mass times velocity squared. So if an object's velocity increases, its energy also increases because energy is directly proportional to velocity. So if energy increases, its mass also increases. And so more is the speed, more will be the increase in mass of that object. Now as the object reaches the speed of light, any extra energy given to the object to increase its speed will not increase its speed, rather will add on to its mass. And at the speed of light, the mass of the object becomes infinite. And to move an object of infinite mass, you need infinite energy, which just isn't possible. And hence nothing can travel faster than or even at the speed of light. So then why are we wasting our time talking about stuff like warp drive, which claims to accelerate things at the speed of hundreds or even 1,000 times the speed of light? Turns out there is a loophole. Precisely speaking, the theory says that nothing within the space can travel faster than the speed of light. It does not say that the space itself cannot travel faster than the speed of light. So according to Einstein, we live in a four-dimensional space-time, and space-time is not static. Space-time can be bent, curved, or even warped. Massive objects like stars and planets bend the fabric of space-time, and in fact this is what causes gravity. And so space can be deformed at any speed, may it be less, equal to, or even more than the speed of light. I like to talk with proofs, so here's an example. At the instant of Big Bang, which was the beginning of space and time itself, the original structure expanded way faster than the speed of light in just a fraction of a second. By the way, you can also check out this video on journey from Big Bang till today. And as we all know that the universe is expanding even today and the galaxies are moving apart, this expansion is accelerating, meaning the farther the galaxies are from us, the faster they move away from us. And so the distant galaxies which are very far away from us are now actually moving away faster than the speed of light. And based on this, Alcubierre proposed the idea of traveling faster than light by warping the space. So it goes like this. If space in front of the spaceship was contracted and the space behind it was expanded in order to compensate, then it would be possible for the spaceship to travel at superluminal speed. This spaceship would remain inside a bubble and the crew members wouldn't feel the magnitude of interstellar journey. It's like you aren't moving but the space beneath you itself is in motion. This can be understood by a simple example. When you stand on an escalator, you start moving and ultimately reach another floor. But think of it. Did you actually move? It's the escalator which was moving and you were still standing stationary. But what does it mean to expand or compress the fabric of space-time? Okay, imagine that distance between 2 points A and B is 10 meters and you are standing at A and can travel at a speed of 1 meter per second. So to travel 10 meters, now you would take 10 seconds. Suppose if we somehow compress the space between A and B to 1 meter, then now you won't have to travel 10 meters. Instead, you have to travel 1 meter. So the time you would take is 1 second. In theory, this approach does not contradict the laws of relativity because you are yourself not moving into the space faster than the speed of light. And this is how Alcubierre Drive works. Well, that's pretty simple. But then, why haven't we made it up to Proxima Centauri yet? After all, this theory was given in 1994 and it's 2021. Well, had it been so easy, we wouldn't be sitting here on Earth even today. Turns out, this theory also has some major practical problems. First of all, the thought of being able to make warp drive possible simply vanishes when it comes to energy requirements. Calculations tell that the energy required to move a spaceship using an Alcubierre drive is only a little more than what is available in the entire universe, which is just not feasible. Another big problem is that you would need two forms of matter to maintain the bubble. First is the ordinary matter. The gravity of ordinary matter would compress the space in front of the spaceship and hence moving the whole structure forward. But remember, at the same time we need something to expand the space behind the spaceship. And in order to make this expansion happen, we need some kind of negative energy or negative mass. This is something which could show anti-gravity effects and would stretch the space. But how is that possible? Nothing of that sort seems to exist. Well, listening to all this, you all might have lost all your hope. But wait a second. Did I just tell you that there are people who are still working on this to make it possible? And also that they have already made significant changes? You would be very happy to know that NASA has a separate research group which particularly investigates on theories which involve futuristic space travel. The Advanced Propulsion Physics Laboratory or EagleWorks Laboratory has been actively working on warp drive possibilities. They have been developing a warp field interferometer and have been testing the possibilities to make warp drive more efficient. Harold G. White, an aerospace engineer at EagleWorks Laboratory and Advanced Propulsion Team Lead for NASA Engineering Directorate, is known for proposing new Alcubierre concepts. White attracted the attention of press when he first began proposing new ideas about warp drive in 2011. He calculated what would happen if the shape of the ring encircling the spacecraft would be more like a rounded donut instead of a flat ring. And to his surprise and your surprise, he found that on making such a change, the warp drive could be powered by a mass of just a small spacecraft like Voyager 1. Remember Alcubierre's model required energy more than the entire universe? Well, this is indeed a breakthrough. Apart from this, two recent papers this year in the month of March, one by Alexei Bobrik and Gianni Martier and another by Eric Lenz, have provided solutions which could bring warp drive closer to reality. Bobrik and Martier realized that by modifying the spacetime within the bubble in a certain way, they can remove the need to use negative energy. This solution though does not produce a warp drive which can travel faster than the speed of light. Independently, Eric Lenz also proposed a solution that does not require negative energy, and his solution does allow us to travel faster than light. This tells us that we have made very major progress in the field, and it could be possible that we will someday in the future make warp drive possible. Well, we should not forget that even though we have made progress in the field, there still are many problems associated with warp drive which we haven't solved yet. And of course, all the progress we have made is on paper, and so we are still far more away from reality. Well, it would be difficult for our generation to witness warp drive, but maybe it becomes a reality in a few hundred years. Who knows what the future holds? Alright then, until we meet again, keep stargazing.